Welcome to the final day of our 6 days AICTE ATAL Online Faculty Development Program on Clean Mobility Revolution, Electric and Hydrogen Powered Vehicle. So today we have three sessions. Let us begin with the session 11. So I request Dr. G. Ramakrishna sir to kindly proceed with the introduction of the resource person. Ramakrishna sir.
Yes, sir. So good afternoon. This is Dr. G. Ramakrishna from Godavari Global University, Mechanical Engineering Department. It is my privilege to introduce the resource person of session 11, Dr. Amarnath Varma. Dr. Amarnath Varma Agani is an accomplished expert in electric vehicle design, battery engineering, control systems, and advanced manufacturing technologies. He holds a doctoral and master's degree in ICT from the Busan University of Foreign Studies, South Korea. With over a decade of experience across EV battery pack development, battery management systems, vehicle dynamics, 3D scanning, reverse engineering, and robotics, he has worked with leading global institutions including the Korea Institute of Industrial Technology and Korea Electric Motor Company. His contributions include the development of innovative lithium-ion battery packs, advanced thermal management solutions, and AI-driven battery aging prediction models. Dr. Amarnath has authored multiple publications, secured 3 patents, and received awards for his research and technical excellence. His portfolio spans EV technology, automation, AI-based smart systems, and advanced manufacturing, making him a versatile and impactful contributor to next generation mobility and energy systems. I extend my heartily welcome to you, sir. Now I am handovering the session to Dr. Amarnath Varma, sir. Thank you, sir.
Thank you so much for your introduction, sir.
Yes,
You,
sir.
sir.
I will share presenter to you, sir. Just a second.
Okay, just wait a moment. I'm sharing my my PPT.
Yes, sir. You can share now, sir.
So,
yes, sir. It
am
is
I visible,
sir. Yes,
okay,
sir. It is visible, sir.
Sure, definitely. Just a moment, please.
Okay, sir.
Okay, what about now?
Now, okay, sir. Now it is
Okay.
in full screen, sir. Okay.
Okay. So first of all, thank you so much for your introduction, Mr. Dr. Ramakrishna, sir. I'm very happy to your introduction. So, okay, today my session is about the development of electric vehicles, the trend, how we are the moving forward to developing the from scratch to electric vehicle. I will explain step by step here. This is my main content here. So for this, before going to this session, first of all, thank you so much for this giving this opportunity to me, just to expose my projects and my research work in front of the some of the professors. Okay, thank you. Then go to today's session. Okay, so previously Dr. Ramakrishna sir already explained, introduced about my educational and my research work and everything. So I'm skip this one. So actually I have some achievement during my PhD and Masters and PhD. So I did some MOUs between the VIMA, Indonesia, and South Korea government. In this one, I did some MOU to development of the two-wheelers JESIT electric vehicle, which is developed by the Indonesia VIMA. So I placed the main role for developing this MOU between these two countries. And also, I also one of the part for this research, I developed a 2.5 kilowatt battery pack with CVT. And also, you know, in India, there is a Murugappa is developing the one electric auto. This name is Mantra something, yes. This is also we are also have some part of this developing this three-wheeler. And also during my PhD, I got first rank for 3 consecutive semesters. So my university is just published about my article, the local paper in the university related papers. They motivated to students. And also when I was in my PhD research time, I got a best appraisal A+ project. So they can publish about me in the Korea local newspapers. These are my achievement during my research. Okay. And also already Dr. Ramakrishna sir said I developed different kind of battery packs and battery related for the electric vehicles and at all. So these are the some of the recent publications I show here, and I have mainly 6 patents which is related for the battery related patents I have. And also I developed the smart fish farm, which is vertical aquarium. I have, this is also patent, and I developed the energy storage systems, that is the energy management system, that is also I have one patent. And actually here the seaweed from the extract from the sea, there is some type of seaweed, so I developed some robot liver for this one, that is also I have one patent. And also I developed the rotary the motor rotary assembly, the new technology, that is also I have some patent for this one. Totally I have 55 publications, and I in the 55 publications I have 8 SSA papers and 13 proceedings and 5 scopus and 29 local papers. These are about my academic research background. Okay. And now I'm coming to my project. How I handling the projects? I handling the different types of projects. In the first one is the battery. This is I developed the expandable batteries. Expandable battery means I can utilizing the single battery module for the multi functions. You know, nowadays actually we can using the different types of robots, different powered robots we are using. For example, the capacity low powered robot, it is a 2 kilowatt we need, but heavy operating, that is the need for the more than 50 or 54 kilowatts like that. In this case, we using the single battery pack, we using the multi-purpose, that is the expandable battery. I developed this battery and I have patent for this one also, for the cooling system and this battery module systems. Okay. And also I have one more sound patent, that is nothing but a cooling system, that is the battery thermal management system. Nowadays battery thermal management is the place, the benchmark and backbone of the battery pack, that is the we should need the cooling systems. I developed and make a patent for this one. This is also cooling systems, battery thermal management system. Okay. And also I developed battery aging prediction system. So you know, actually mostly nowadays most of the in Korea, I don't know about the India side, in Korea and some Europe, they are divided into battery aging prediction. There is the 2 types. One is the physical type, another one the chemical type. So physical type means we can check the battery charging, discharging, and a DOD like that. And coming to chemical predictions, we can using the anode cathode and how the degradation of the anode cathode they can checking. But these 2 methods, it is the inaccurate. We can't give the exact prediction for these 2 because of so complex loads. It won't work. That's why we are applying the new technology, that is the hybrid battery aging system. In this hybrid battery aging system, we can adapting the physical and chemical and combining these 2. So physically what we want to do, DOD pattern we can, and capacity fade, how it is happened, and internal resistance, how it is rising. We are identified physical side, and chemical side, anode and cathode, how the degradation is happen. So in this case, we combining these 2, then we can predict the accuracy and exactly battery aging. Okay. And coming to, I have another project, that is the PCM based thermal management system. Actually, everyone know cooling system mainly classified into two types. Type 1 is nothing but a active cooling system and a passive cooling system. Active cooling system is nothing but a liquid cooling or air, this kind of things, active cooling system. Passive cooling system is nothing but a heat pipes and some other add the external materials like a PCM like this. So it is nothing but a active cooling passive cooling system. In this one, what we want to do, we are applying the some PCM, means phase change material. It can be absorbing the heat from the battery, keep this battery, when the battery is required heat, it can be the return to the battery. That is the technology. We are working with together with Sanggu High Tech. It is also Korean company, and also in India, Chennai also established this company. We are working with this company and we have developed this battery pack with them. And also I developed for the two-wheelers micro mobility battery pack. So during my Indonesia MOU, at that time I developed a 2.5 kilowatt battery pack, and I tested this one and we successfully operated this battery pack, and we got this project is A plus. So this is also in this battery, in this project, I developed the 2.4 kilowatt with lithium ion battery with a thermal management system and high current density, and increase the mileage of the vehicle. That is our main concept. Previously, the vehicle mileage is 50 kilometers, but we are increasing up to 120 kilometers. Same capacity of battery. That is our main technology. We are implemented and we are developed and we are tested also this one. So coming to my some other projects. So this is the, I developed the steer by wire. Steer by wire means there is no need for any steering column in between the, you can see here, there is no steering column. It is operated by a wire only. There is no steering column. We are operating wire only. Means in this case, we can effectively and prevent of the accidents and complexity. Main technology we are developing, this is steer by wire. I have, then also I have developed the advanced manufacturing, that is the KUKA robots, pick and place robot. KUKA robots we are operating for the milling operation. In Korea, in South Korea, we only having this KUKA milling robot operation. Europe, USA, they existing, but in Korea we are the first time we are operating like this one. And also I have much more experience about the reverse engineering. For the we are the scanning the vehicles or any equipment, and then we can be, sorry.
Dear participant, please mute yourself. Okay, sir, you can continue, sir. No problem.
Okay. So we are reverse engineering means we can scanning and developing the mesh, and then after that we can developing the real model. This is our main concept for this one. This is reverse engineering. So it is nothing but a adaptive manufacturing. So I have good experience in the adaptive manufacturing. Okay, and also I developed the smart fish farm. Smart fish farm is nothing but a, nowadays most of aquaculture is on the earth pond type, but we are first time we are developing this one, the vertical aquarium. I have this one patent also. In this one, vertical aquarium means the vertically we are farming the fish tanks, and then we can growing the fish at the time, and also no need for the any human interaction with this aquaculture systems. The human can away from the this field, they can stay in other place, they can monitoring, they can controlling. For this is also we got the A plus project. We are successfully installed in one of the land from the, which is government provided some land. We are installed, we are successfully operated, and we are successfully finished this project. And I have one more project, that is the, we are developed the fish robot. Fish robot means which can be the monitoring the slugs or some some unwanted things in the deep of the water, we can monitoring purpose, we have developed this RoboFish. This RoboFish also, we are developing the, since my masters with my colleagues and my professors, we are developing the systems. Okay, this is, we can see here the fish motions. Actually, we are applying here different kind of technologies, algorithms for the controlling the fish with respect to, we are operating the green band like that. Okay. So up to here, I explained about my research work. Now we are going for the electric vehicle technology, how we are developing the electric vehicle technologies. Okay. So when we want to develop a electric vehicle, we need some important note. That is, first of all, define the purpose of required. What is the purpose we want to develop the electric vehicle? Either it is agriculture base or passenger base or any special purpose base or some using for the heavy duty phase. So we should be defined the purpose, and after that we can select the what type of vehicle we want to use. For example, powertrain, what type of powertrain is very important. We're using the pure electric vehicle or hybrid electric vehicle or range extended vehicle. So everything is different way for the with respect to utilizations. Okay, and also after that, when we define this one, and then we can do the some analysis for this one. Okay, after that we can integrated these things, and then we can select the core hardware what we want to need. Okay, that is very important. So up to here is very important. So up to 1 to 5 steps we are discussing now. Okay, going to here, actually we are planning to develop a REV, means range extended electric vehicle. So when we want to developing the range extended electric vehicle, first of all we want to know what is the range extended electric vehicle. Range extended electric vehicle means if you go for the pure electric vehicles run by motors only, there is no battery source. Okay, when the battery is finished, the vehicle is stopped. If we are going for the hybrid electric vehicle is nothing but it is run by either either engine or battery. Okay, that is the main purpose we are using the hybrid electric vehicle. So coming to range extend electric vehicle, which is nothing but it is purely electric vehicle, but we are always recharging battery with using the IC engine. So there is a IC engine. The IC engine is run. When the IC engine is run, then it can be generating the they are attached with the generator. The generator will be generating the power. This power is going to the battery, then battery driven the motors. Okay, it is continuously running. Okay, when the battery is full, the engine will stop. Then it can be run by the battery. When the battery is going down, then automatically engine start. Then again generator will be generating the power. Then battery will be the filled. This is nothing but a range extension electric vehicle. So now I am doing this project in my company. Okay, so in this project I'm mainly participating. Number 1 is the battery pack. Number 2 is the engine with generator. Number 3, motor. Number 4, axle. Number 5, steering system. Number 6, VCU. Okay, vehicle control units. So I will explain here step by step about these things. Okay, so first of all, expandable battery. Already I explained previously this about the battery pack. This battery pack is nothing but actually for this vehicle we are using for the 34 kilowatt battery pack. So it is always filled by the engine. Okay. So next we will come for the second one is we are choosing the engine, that is the hydrogen engine. Why we are choosing the hydrogen engine? So we know nowadays the vehicle is classified into two types. One is the IC engines, another one is the electric vehicle. IC engine is running with petrol or diesel. This petrol or diesel, okay, it can be run with the fossil fuel. Okay, this is actually purely run with engine. Okay, this is a pollution. It has a pollution because of it is operated with fossil fuel. Okay. Okay, coming to electric vehicle, I'm using the hybrid electric vehicle. Hybrid electric vehicle, how it is operating? Hybrid electric vehicle, I have a battery and also fossil fuel. Okay, then it has a engine and a motor. It is also have some pollution because of we are run by sometimes engine. Okay, coming to plug-in electric vehicle. Plug-in electric vehicle also like a hybrid electric vehicle. There is no difference. Okay, if you are going for the electric vehicle have purely run with battery, okay, and motor. It has no pollution, but it has some restriction for the mileage. Okay, we can operating such a some restricted distance only. So if we want to more, we should be recharge. Recharge means, sorry.
Dear participant, please mute yourselves. Dear participant. Okay, sir, you can continue, sir. Amarnath.
Okay, yeah. Okay, so we are going for the, it has some mileage restrictions for this one. So okay, then we want to recharge. It will take very long time. Why? Because of charging is nowadays the major research is going for the how quick we want to recharge charge the battery. That is nowadays most hard research is going. So we are coming to next. It is operated by the hydrogen range extended electric vehicle. Hydrogen range extended electric vehicle means it is operated with engine and motor, but there is no pollution. We can extend the range. Okay, so we can possible to reduce the some of the problems regarding the electric vehicle. So we can extend the range. Number one, we can satisfy the electric vehicle. We can reduce the pollution, means we can satisfy the prevent the pollution. These are the main things we can do here. That's why we are going for the range extension vehicle with hydrogen engine. Okay, so first of all I will give the why we are using the hydrogen. Okay, the hydrogen, for example, we can use the IC engines. Okay, it can be the fossil fuel. It is anytime it can be the complete, and it can be output is nothing but a carbon dioxide. Okay, it can be harmful, and it is the compared to the any electric vehicle, the combustion effect is the 20 to 35 only. Okay, that is also, so we are wasting the most of the fuel in this case. The remaining things will be the go for the existing is the CO2. Okay, so if you are coming to the electric so hydrogen fuel, it can be the zero pollution. Okay, and also it is combustion efficiency is the 60%. Okay, and also it can be the noise very low, vibrations very low. Okay, it can be sustainable the renewable energy. Okay, that's why we are going for here. Then we have another question. So some of the people maybe in mind there is the why you are using the rotary engine. Rotary engine is the not good for the efficiency. Mostly they are thinking like that. No, rotary engine, if you are applying the most load and long time, it can be the bad efficiency. If you are using the less load and the less distance, less time operation, it is a very powerful and very good efficiency than compared to the IC engines. That's why we are going for the rotary engines. Okay, so our plan is why we are choosing there is another alternative also, why we are choosing the rotary engine. Rotary engine not only for the electric vehicles, we can apply for this one also, drone. So very compact, very light in weight, we can we can adaptable any kind of things. That's why we are going for the rotary engine. Okay, so number 3 is the motor. So actually this motor have some special special features in this motor. Actually nowadays motor is nothing but just we can develop the stator, rotor and shaft, we can connecting the wheel. No, that is this motor is we are purely developed with inline differential. Inline differential means you can see here there is a 2 motors. This is the stator rotor and the stator rotor. There is a 2 motors. Okay, this is 2 motors with differential means the motor with differential means there is complexity is very less, and also it can be give the very good efficiency than compared to the normal differential. Okay, that's why we are developing this inline differential motor. Okay, already we are developed this one. You can see this is the inline differential and this is the differential motor. I don't show here my motor because of that is the some my company restrictions. I don't show anything. Okay, I will show only for the some of the rough things. Okay, so after that we can go for the axial with suspension. So we have 2 types of axle here. Model 1 is the reduction gear and motors. Okay, reduction gear and motors we are using normally this one with the double wishbone suspension system. So another type is we are the inbuilt differential model. Okay, this is our model. We developed these 2 models now. Okay, it is under processing these 2. Okay, then number 4 VCU. This is the very important and hot topic nowadays. Vehicle controlling unit. This vehicle controlling unit we are adapted with SDV, means software defined vehicle. What is the software defined vehicle? So we know we are like every day we in a human life they are using for the mobile. What is the purpose of mobile? Mobile we can using for the contact for some other persons. We can using for camera, gaming and calculators, movies, everything we are using the mobile. Means one phone, different applications. Okay, there is a one phone but there is a different applications. Like that we are coming to the common hardware but multi functions. For example, I'm using for the ladder type and sometimes I'm using the 3D printing type. Sometimes I'm using the agriculture purpose, and sometimes I'm using the woodcutter. This is so nowadays mostly this special purpose vehicle, each function they are using the each vehicle means. So in this case every function there is a required one vehicle, but our technology one vehicle multifunction means we can reducing the quantity of the vehicle and the functionality of the vehicle is huge. Why? Because of some of the vehicle, if you are going for the some cold countries like South Korea, Europe, any other country, in the winter they are using for the snow pillars. Snow pillars only utilizing for only winter, remaining summer and rainy they don't using anything. Some sweeper, we can go for the sweeper they are using only summer, remaining rainy and snow season, winter they don't using anything. A ladder, the ladder type vehicle they can using particularly some of the if required, or else it can be idle. Means every vehicle most of time there is the idle means they don't using this vehicle, but our function is our vehicle every time we can use it. Winter we can using for the snow filler, in summer we can using for the sweeper. So if we required we can use it for the ladder. So means one hardware multi functions. Okay, that's why we are developing the software defined vehicle. Software defined vehicle means hardware is same but functions are different. Okay, so what type of functions common and this one? So common platform we can using for the hardware standardized. We don't use for the multi functions for that one, but It is just software app standard. For example, I'm just we have different apps I want to use for the gaming. Just installing one app, I can play game in my mobile. If I want to using some bank account, I can develop I can installing bank related app, I can use for the bank purpose. Means like that, I can, for example, I want to use for the sweeper, just a sweeper related app I can installing. Just a small hardware will change, not just a small. For example, sweeper means we can attaching the some motors, that's finish. It can go for the operating sweepers. Okay, like that. And also it can be always using for the OTA. OTA means we can the communicating with the data with vendor and vehicle, they can be the communicating data. Okay, and coming to this one, software defined vehicle, why we are the special purpose vehicles. Previously I said, so normally the ladders, they are in commonly they using the two people. Actually one person will be stand on land and another person in the ladder. So ladder person will be the give the instructions to land person, please move the left side or move the right side, you can move the up. It can be some strange things. Sometimes he is operating wrongly, then it can be a hazard for the ladder person. So if we are updating this one SDA area, software defined vehicle, it can be the operating one person. There is no need for an extra land person. He can be monitoring and joystick everything. He can operating and he can go what they want, the target achieving very easy. That is our main thing here. And also here one more thing is reducing the risk. How to reducing the risk means, actually every ladders, for example, there is a operating certain height and certain angle. If the more than this angle, the load is undistributed, then it can be the fall down. But when you are updating this software defined vehicle, it can be the restricted for the maximum height, more than that height, and restricted for the required angle. Okay, more than the required angle it can be restricted, more than the required height it can be restricted. So within this parameter we can use this one. Okay, and also coming to the seasonal operation, previously I said we can using for the different seasons and different vehicles. Means we need several vehicles. We can do 3 vehicles, but we can using the single vehicle for the multi-functions. So in the summer I can use for the sweeper, in the sometimes I can use for the ladder, in winter I can use for the snow pillars. Means one vehicle but different functions. And industrial service is there. Industrial service means we can use it for the laddering technology and printing technology. We already established this one. So nowadays the apartments painting, or we can banner printing and everything, they can do the some manually like that, but we are adapting this one for the vehicle. When we give the program, automatically the vehicle will be the printing the object. And also 3D printing technology. 3D printing technology nowadays they can use the very huge vehicle, they can installing, they can operating, but this is not like that. Just we can give the program, it can be the fix the base, then it can be the printing the what we need. This is our new technology. We are developing SDV for SPV, means software defined vehicle for the special purpose vehicle. We are under researching this one. So this point of view, some people have some questions. Why, how to updating the program? Means, for example, I have, so OTA means it is nothing but a, we can this on the air we can communicating with the vehicle. So when we need, the customer will be the updating the app in the vehicle in the mobile, then it can be the automatically integrate with the vehicle, then it can be the communicate with the VCU. Then VCU will be collecting this information with respect to what we require. Then it can be that program will be automatically established in vehicle. Just we can change some, for example, here you can see here the basket. We can remove this basket. We can just paint spray here. Then it can be the paint work. If we need for the printer, just we can remove this sprayer. Then we can replace with paint nozzle, print nozzle. Then we can use for the 3D printing. That is our main technology to developing here. And here how VCU is working. Vehicle controlling is nothing but here it is integrated with the app developer, manufacturer, customer and hardware. So when the app developer developing some apps, how they developing, the manufacturer will be the commanding to the app developer. They need to develop some vehicle with respect to sweeper, ladder, printer and painter. So this requirement they providing to the app developer. He will developing some program related for this one. Then the customer will be the operating this with respect to what they're providing, updating these things. Then they will operating this vehicle. So when this vehicle is operating, the manufacturer will be the monitoring this data. So how the ladder is working, how the life of the ladder, how the spray nozzle life, and how the motors, the sweeper motors, how it is working, and then when we using the paint, how the paint arm is working. This everything data will be the monitoring by the manufacturer. If there is any problem, means for example the life of the ladder will finish, then they will updated or information to the customer, so they can take this vehicle to the service and they can re-upload this one, they can utilize it. And also when the vehicle they are upgrading, then he can providing some information to the again developer. Then developer will taking the instruction from the manufacturer. With respect to manufacturer, they can updating vehicle with respect to different types of things. So that this everything is run by the VCU, means vehicle control unit. Okay, so how the main frame is working, you can see here. Actually app developer developing the what the customer manufacturer provide. Then the customer will be operating these things. When the customer will operating app, then he can execute it for these vehicles. So when the vehicle is executed, at that time the data, sensor data is going to the manufacturer. He can monitoring and analysis and update it. And if there are any issues, they can send message to the customer. Then customer can be the taking to the customers the service station. They can rectify the problem and they can using. At the time also the vehicle will be upgraded. For the this year is actually using the some AFPM motor. Next year they can using for the improve the power. Nowadays they can 2 kilowatt. Next year they are planning to use for the 5 kilowatt. Then this data will provided again to the app developer. Then he can implement these things. Then again he provide for the updated app. Then our customer will updating this app, again reusing. That is the main function of this SDV. And also this is previously what we see, it is the client side. This is the within the developer side, how the developer is working. Previously explained, same as here function. And here in the SDV there is a main key functions. Number one, development of software development platform, SDV, hardware and app. These three are the very important for this technology. So coming to the software defined ecosystems. In this system, what we want to do, we are providing here security and the centralizing and the service oriented softwares and secure OTA. Okay, and the life of the vehicle we can estimating here. Okay, the role of the SDA platform here. Okay, and after that we want to do here, what we want to do for this one, very important thing is the motor controlling units. So commonly nowadays, if you are using this kind of things like a ladder and everything, they can using the different, actually you can see at the different motors, different switching units and different controllers. Means each joint have one motor, one controller, one switching. Means here the VCU can controlling the VCU can't modify this controller programming because of it is the each controller have the dedicating program. So if you want to change this one, entire motor, controller, switching, everything we want to change. Okay, but our plan is this is the normal using model, but we are applying for the SDV. In the SDV technologies, we are using the VCU directly controlled by the one controller. This one controller can be control the switching and motors. Means always we can modify under rechangeable and rewritable program with respect to VCU because of commanding the VCU with controller. Okay. And after this is the multi-layer inverter, how we are using developing the inverters. So traditional inverter, there is a just battery is going to the switching to operating the motor. So each one is the inverter, but our technology, we are using the one amplifier and one controller, different multi switches and multi controllers. So VCU can always monitoring and update the program here. Okay. So here have AppCore technology. Why we are using the app technology means we are developing some application for the Android and Google Play stores. Okay, and we are developing the operating systems, and we are developing the OTA with respect to cloud system, and we are supporting for the driving technologies, and we are developing the app, and we are providing the cyber security for this technology. And this is the how the software is defined vehicle with the integrating with the insurance and government. So for example, nowadays if you are commonly used vehicle, then they are not providing for the any security because of they are just utilizing themselves. There is a risk. For example, ladders, we can operating certain height, but they are using more than that height, it can be happen accident. So in this case, the insurance people will be the worry to providing insurance for this kind of vehicle because of there is no proper security. But if they are updating the SDV, means it can be the not operating for the worst conditions, and the what we required height more than that height, it can't work. Means the insurance people will be satisfied because of it can be working under the safety reasons. That's why the insurance people will be the adapting this technology, and also government also providing some benefits for this technology because of they can providing safety. That's why they can easily providing subsidy regarding these things. And also we are providing service maintenance for this one and customer values. These are the main things under this technologies. Okay, so for this one we are planning to implement this one for the bench unimog vehicle. This vehicle already we are planning to implement this technologies. Now it is undergoing the processing and we are doing this project. Okay, this is my today presentation. Thank you so much. I hope you are understand and it is some knowledgeable for you. Thank you.
Thank you very much, sir. Thank you very much, sir. Dear participant, the session is open for question and answers. If you have any questions, please ask. Dear participant, the session is open for question and answer session. Sir, Amarnath sir.
Okay.
So I have one doubt, sir. Actually, I asked it in previous session, but I'm not fulfilled with that answer. Actually, we are moving towards the electrical vehicles, sir. Most of the electrical vehicles are getting energy from the thermal power plants only.
Okay.
Okay. Actually, we are saying that we are shifting from the polluted vehicles to the green vehicles.
Okay.
But even though we are consuming the power which was developed in the thermal power station, sir,
Okay.
then how we can justify, sir?
Actually, coming to other countries, the thermal
Yes, sir.
power is reducing. They are planning to using for the solar power, number one. Okay.
Yes, sir.
Number one is solar power. Number
Yes,
two
sir.
is if we are going for the actually we have another project, that is the under processing project, that is we are developing the vehicle, solar roof vehicle.
Yes, sir.
Solar roof vehicle means the vehicle will charged when the ideal condition, only ideal condition, not running condition. Okay.
Yes, sir. Yes, sir.
Only ideal condition, the vehicle will be the charging using
Yes,
the top roof of the bus or trucks.
Yes,
Okay.
sir.
This is also one project. So also thermal energy, yes, thermal energy also one of the pollution too. We can make the generating the power. Mostly nowadays they are going for the solar energy or else nuclear energy or else wind energy. There is different kind of energies as going on. Okay.
Yes, sir.
So we can utilizing for this one another type or else
Yes, sir.
we need for the energy battery. For example, I give the some example here. Range extension vehicle mostly neglecting the outsource of electricity. They no need for the any plug-in charging because
Yes,
of
sir.
when the engine is operating. So engine, we are developing the hydrogen engine. Hydrogen engine means there is no need for any fossil fuel. We are using the clean hydrogen engine.
Yes,
So
sir.
the green energy, utilizing for the green energy, and we are output also zero pollution.
But hydrogen production also, it will develop some pollutions, no, sir. When you try to develop hydrogen, there also there is a pollutions are generating.
So but compared to thermal
Yes,
energy
sir.
and the fossil fuel, it is less, very less.
Yes, sir. Yes, sir.
Okay.
Yes,
And
comparatively it is
also
okay, but yes, comparatively it is okay. Less, it is developing less pollution than the conventional engines.
yeah,
But
of
even
course.
though we are saying that we are shifting to green vehicles, so in that concept, I am asking. Okay.
Actually, my answer is everything have some disadvantage.
Yes, sir. Yes, sir.
Even we are using the solar energy. Solar energy also have some pollution to the earth. Okay.
Yes, sir.
So without disadvantage, there is no advantage.
Yes, sir.
Okay. So
Yes, sir.
what we think, how to reduce the disadvantage, how to reduce the effect of the environment, how to reduce the fossil fuels, and how to improve the green energy. That is very important. So
Yes, sir.
we can look everywhere there is a pollution. We
Yes,
don't
sir.
say this is 100% the green energy. Nothing.
Yes, sir. Yes,
Nothing is
sir. Absolutely. Sir, another question, sir.
okay.
Actually, the whatever efficiency of the electrical vehicle, it may be depends on the heat transfer of the batteries and heat transfer of the motor, sir. How you can justify, sir? What type of cooling
Yeah.
system we can adopt for the batteries, and what type of cooling system we can adapt for the motor, sir?
Yes. Okay. I
Optimal.
will. So first of all, we want to know the what kind of battery we are using. Lithium-ion
Yes.
battery, MNC battery,
Yes, sir.
or lithium polymer batteries. There is a different chemicals. Okay.
Yes, sir.
For example, I will give the some example. Samsung SDI is developing the different kind of vehicles. Means so battery from the there is a battery thermal management is the different layers. First layer is the cell position. Cell. When you
Yes,
come
sir.
to the cell,
Yes,
there
sir.
is a anode, cathode, electrolyte. Okay, anode, cathode, electrolytes.
Yes,
They are
sir.
very important.
Yes, sir.
What kind of lithium salt you are using? What
Yes,
kind
sir.
of solvent you are using in between the medium from the anode to cathode?
Yes,
What
sir.
kind of anode and cathode you are using? How to prevent the layer? We want to generating the layers. When the electrodes moving from the anode to cathode some certain speed, it can be hit the edge of the anode. It can
Yes,
be
sir.
damaging the battery. At the time it can be generating the heat. How to prevent to hit this one? We can make some layer.
Yes, sir.
How to now technology, the Samsung SD developing this one, they can making some layer, so hit the electrodes with the layer, not the anode or cathode material, then it can be safe, stable, means and also they can adding the adaptive materials in the solvent for the control the temperature, how the equivalent the temperature, that is the cell side. Coming
Yes,
to the
sir.
battery side, when the come to the battery side, how you can make the ventilation in between the cell to cell. Okay, what type of cooling system you are using. So for example, what type of cell you are using the prismatic cell, pouch cell, or cylindrical cell. Cylindrical cells are different and pouch cells are different. What type of cell you are using for the battery pack? For nowadays they are focusing, Samsung SD and other companies, they are looking to making for the cylindrical batteries, that is the 46 series, 4680, 4695, 4611, 100, 4621, 120 batteries. Why they are focusing cylindrical batteries? Because of pouch batteries are, the surface content is very high. So you are going for the cylindrical battery, there's like this, in between there is a gap, the some of the energy released, but it is not affected by the thermal energy. So how we can design, that's very important. That's why when you making the battery pack, how to prevent the energy, how to evaluate the waste energy for the outside, how to make the ventilations, what type of chemicals you are using, that is the very important.
Okay, sir. Thank you. Thank you very much, sir. Sir, we have a question in the chat box, sir.
Okay.
So they're asking type of PCM used and stages of PCM characterization process conducted for your PCM based BTMS experiment, sir.
Okay.
They're asking.
So actually we are using here 4 types of PCM materials: ruby therm type and expanded graphite type of PCMs. So actually you can see here, that is the RT15 and EG28. 28 means that is the melting temperature. So of course he know very well about, maybe asking about the Rao Kuren Daniel.
Yes, sir.
Asking
Yes, sir.
So when we using the PCM characters, what is that one? It can be when the heat is absorbed, it can be changing the characters from solid to liquid. Okay, so in this case, we are observing the when the melting point start. Okay, the heat flux, when we can be the melting point start, we are observing that point. We are identify that point. Then we can we can choose the PCM materials. So in this case, we are doing the different kind of experiments like extreme heat and extreme cool, and then what condition it can be the melting and what condition it started to melting and freezing. We are identify these points and we are utilizing this material for the battery pack.
Yeah, dear participant, any other questions from your side? If you have any questions, please unmute yourself or you can mention in the chat box such that Amarnath sir will answer
Yes,
those
yes.
questions.
I got one more question here.
Yes, sir.
Yeah, why we are choosing the PCM material? Actually, PCM material we are using for the that is the reason. Sorry, that is the reason why we are using, because of there is no need for the any external source. We are using for the liquid cooling system or fan cooling system. there is a certain conditions we are using. For example, we are applying for the water, and there is some complexity. That we need water, we need the pump, and we need the fan and everything. Okay.
Good afternoon,
Sorry.
sir.
Okay.
Hello. Good afternoon, sir.
Okay.
Sir, good presentation. First of all, thank you so much for your presentation.
Mhm.
Sir, I was asking about the PCM type. I have a doubt. Basically, like PCM, for
Mhm.
thermal management aspects, I feel it is a good solution. But when it comes for thermal runaway scenarios, like if there
Mhm.
is a possibility of heat accumulation, then it can also go on the negative direction. Like it can pass on the heat to the nearby cells.
Yeah, of
So,
course, of course.
so in my question is
Yes.
based
Yes,
on
I
that.
agree with you. I understand now clearly. Yes, okay. Yeah, this is the some disadvantage. Yes, that's why we are currently we are not using for this technology due to these problems. Okay, the problem is it can be the absorbing the heat, and at the time compare the heat displacement condition, it can give to the another equipment like a other side of wall and these things. Yes, it can be failure for these things. Okay.
Okay, sir. Thank you. Thank you so much.
Dear participants, if you have any questions, please ask. Amarnath sir is going to answer your questions. Amarnath sir.
Okay.
Sir, if there are no questions, we will try to have wind up this session, sir.
Okay.
Okay, sir. Sir, thank you very much, sir. You are wonderful information. So very valuable things you given to today's session. Thank you. Thank you very much, sir.
Actually,
Sir.
Dr. Rojo Corin Daniels, can you you can ask me some questions? Please send me mail. I will give the proper information for this one. Okay. At the time, I can't see your message here clearly. Okay.
Okay, sir. You
Got
can
it.
drop.
Sir. Thank you. Thank
Okay.
you, sir.
Okay. Please. Okay. 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 Sure. Definitely. Okay.
Thank you,
Thank you.
Amarnath
Thank
sir.
you so much.
Thank you very much, sir. Amarnath sir, once again. Dear participants, we will take 5 to 10 minutes break. Then we'll start with the another session. So we will take 5 to 10 minutes break. Then we'll start our next session.
Okay, sir. Okay.